In section 3, we're going to take a look at direct variations. The formula for a direct variation is y equals kx, where k stands for the constant of variation. In a direct variation, k cannot be equal to 0, but the y-intercept must be equal to 0. What direct variations show us is a proportional relationship between y and x. Now, from this formula, you should be able to see a similarity to slope-intercept form. Slope-intercept form is y equals mx plus b. All we do is we take the m out of the formula and plug in k. The reason why we don't have a b is because we know that the y-intercept has to be 0, so there's nothing to be added to the kx. If you have a y-intercept other than 0, then you don't have a direct variation. An important characteristic of direct variation is that we have the ability to move the variables around in the equation to get to different places. So we take y equals kx. If we want to isolate the k, then we would end up with k equals y over x. Y equals kx and k equals y over x are the exact same equations, they're just ordered a little bit differently. Or if we wanted to, we could take x and we could isolate x, and that would give us x equals y over k. In this first pair of problems, we're going to identify direct variation from a table. So for each function, determine whether y varies directly with x. If so, what is the constant of variation and the function rule? So we're given in this table that when x is 1, y is 2, when x is 3, y is 6, and when x is 4, y is 8. So to determine if y varies directly with x, there's a very simple procedure we can do, and that is to divide y by x in each of the pairings. Remember that k equals y over x. So if we do that to the first pair, 2, 1, we get 2 divided by 1 equals 2. 6 divided by 3 equals 2. And 8 divided by 4 equals 2. So since the k value, or the quotient of y divided by x, is the same every single time, we know that these are proportional to each other, and that there is a direct variation and a constant of variation in these pairings. So since y over x is the same every time, the table represents a direct variation, and the constant of variation is the result of y over x. The function rule, all we're going to do is take y equals kx and substitute what we know k is into that formula. So it becomes y equals 2x. That's our function rule. We're going to do the same thing in 1b. So again, start by dividing y by x. 4 divided by 1 is 4. 8 divided by 2 is 4. But 11 divided by 3 is 11 over 3. So since y divided by x is not the same every time, this table does not represent a direct variation. In this next set of problems, we're going to identify direct variation from equations. So for each function, determine whether y varies directly with x. If so, what is the constant of variation? So our problem is 3y equals 7x. What we want to do is isolate y. So when we isolate y, we're just going to divide by 3, and that gives us y equals 7/3 x. The thing that we're looking for is the presence of a b value, or a constant. There is no constant in this equation, so that means that this is in fact a direct variation. The constant of variation is going to be the coefficient for x, and that is 7/3. We'll do the same thing for part B. 7y equals 14x plus 7. Divide out the 7, and you're left with y equals 2x plus 1. Since we have a b value that is something besides 0, this means we do not have a proportional relationship between y and x, so this is not a direct variation. Now, when we get to more complicated problems, we can solve direct variations in one of two ways. We can either use a proportion, or we can go through a series of steps to get to the correct solution. So our question is, suppose y varies directly with x. Whenever you see that statement right there, you know you're starting off with y equals kx. And y equals 9 when x equals negative 15. What is the value of y when x equals 21? So since we know that we've got a direct variation, we can just set up a proportion. So what is our y value? Our y value is 9, and then our x value that's associated with that 9 is negative 15. So we go 9 over negative 15 equals, then what is the value of y for the second part? We don't know, so we're just going to plug in y in the numerator, and then x is 21, so we've got y over 21. Cross multiply, and we end up with negative 15y equals 189. When you divide out the negative 15, you're left with y equals negative 12.6. So when x is 21, y is negative 12.6. In problem number 4, we're going to work out the step-by-step way. So it says a salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So again, we see that a salesperson commission varies directly with sales. So the commission is going to be y, and the sales are going to be x. So we're going to do y equals kx. Now we're going to substitute in what we know for those values. The sales were $1,000, so we're going to put 1,000 in for x. The commission is $85, so we're going to put 85 in for y. When we divide the 1,000 out, we're left with k equals 0.085. So this is the constant of variation. What we're then going to do is substitute the constant of variation back into our direct variation equation. So we'll have y equals 0.085 times the sales for the next part, which is 2,300. So we do 0.085 times 2,300, and that means that on sales of $2,300, the salesperson is going to make $195.50 on commission. In problem number 5, we're going to graph a direct variation equation. And you should already know how to do this because you can already graph a line. So the one key thing that's different between graphing a normal line and graphing a direct variation is that our line in a direct variation always has to go through the origin. Every single time, never a doubt, it's going to go through the origin. So take a look at the equation that we've been given. Y equals 3/4 x. So again, for direct variation, we know that the y-intercept is going to be 0, so go ahead and put your point there. Then we look at the 3/4. That 3/4 is the k value, but remember it's also the m value or slope. So what we know is we've got a rise of 3 and a run of 4. So place your next point at that part of the coordinate plane and then connect the 2 points and you're done. We're going to go ahead and get a little bit more practice in with this. So let's take a look at y equals negative 2x. Again, for direct variation, the y-intercept is always 0. So go ahead and put a point at the origin. The rise is negative 2 and the run is 1 because we have a k value or an m value of negative 2. So that means we're going to go down 2 units and right 1. Or we could go up 2 units and back 1. Once you've drawn your point in, connect the points, and you're done with this one.